Okay, so for today, we're going to start talking about solving radical equations. Okay, so some things to remember when we solve radical equations. The first thing is when we take the even root to both sides of an equation, it creates a plus or minus. This is not something new. So if I have x squared equals 4, and we take the square root of both sides, we get x equals plus or minus 2. Right? Now in this homework set, we might be using radicals other than the square root. We might use cube roots or fourth roots or fifth roots or whatever. I only get the plus or minus, though, for even roots. Square roots, fourth roots, sixth roots, eighth roots, etc. make plus or minuses. Cube roots, fifth roots, seventh roots, ninth roots, etc. do not. Okay? Everybody good with that? Yes, of course. So if we're solving a problem where there's an even root in it, by even root we mean square root, fourth root, sixth root, etc. We have to make sure that we're checking our answers, because it is possible that we can get extraneous solutions here in these sorts of situations. Okay, everybody all right with those two things? Hopefully those aren't huge surprises. Hi, Andrew. Let's look at some examples here of the kinds of problems that we're going to be solving. So we'll start from things that are fairly straightforward and progress to things that are perhaps rather complicated. So let's say we're taking the cube root of 2x plus 9 equal to 3. And we want to solve this for x. What's the first thing I have to do in order to get that x by itself? I have to get rid of the cube root in order to get at the stuff underneath it. To do that, I'm going to have to cube both sides of the equation because a cube is going to cancel out a cube root. Is everybody okay with that idea? And then 3 to the third, important here that you guys make sure you're actually using an exponent there. Common mistake I see students making is them doing multiplication. 3 to the third is not 9. 3 to the third is 3 times 3 times 3. That's 27, not 9. And then from here, it's quite easy, right? What would I do next? Subtract 9 and then divide by 2. Everybody feel good on that? Okay, let's try another. What if we have 2 times the 5th root of x minus 3 plus 1 equals 5? What would I want to do here on this one first? Subtract the 1. Good. And then what next? Divide by 2. Good. Now what? Okay, what? I'm sorry, you mumbled something I couldn't hear. I'm sorry, I still couldn't. Okay, cancel out the 5th root. And how are we going to cancel the 5th root? Not multiplying. We're using a power of 5 or an exponent of 5. So again, be careful there. What we're using is not multiplication there. It's a exponent. 2 to the 5th is 32. Just FYI, make sure that we're using an exponent there, not 2 times 5, 2 to the 5th power. And then we can just add 3 to both sides, right? So far, so good? These ones shouldn't be too bad, right? They should feel fairly similar to things that we've done before. The solving process there should feel quite comfortable. But remember, we could represent radicals also in an exponential form. So let's look at a couple of examples there. So let's say we have 4x to the 2/3 equals 36. What should I do first on this one? Again, we're trying to get x by itself because we're solving. I would do something before I worried about the exponent. Dan? Divide both sides by 4, right? So remember that when we're solving, we're really working the order of operations in reverse. And because exponents come before multiplication, when we're simplifying, when we're solving, multiplication should be undone before the exponent is. Everybody's okay to hear? All right. Now I need to cancel out this exponent of 2/3. What's going to cancel out the exponent of 2/3? What exponent can I use to cancel out the exponent of 2/3? Well, remember if I do that, I'm going to be doing this, and the exponents would multiply, and 1/3 times 2/3 doesn't cancel out. Yeah, we'd use the reciprocal exponent, 3/2. Good. Now here's a place where we have to be quite careful. What type of radical is 3/2? So remember here, this rule, what part of the fraction tells me the index of the radical? The denominator, right? So what type of radical did I do to both sides? Square root, but more specific, or more broadly, an even root. Because I did an even root to both sides, what do I have to make sure I do here? Plus or minus. This is a place where students are almost always forget to do this because it doesn't look like you're taking the square root of both sides, even though you did. So please, 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 please be quite careful here. If I did the 9th root, or I'm sorry, if I did 9 to the 3/2, I get 27. I did that in my head, aren't you impressed? It's not that bad. 9 is 3 squared. 2 times 3/2 is just 3. So 3⁵ is 27. Am I done here? Yes, it's okay. We didn't have to check. Because if I look at the beginning problem, this is an odd root, right? So we don't need to worry about checking. Even though we had to take the square root of both sides, that's okay. Doesn't mean we have to check. Matters if the original problem was an even root to start. Is there any harm in checking this? No. So if you're not sure if you should be checking it or not, just check it. Doesn't cost, doesn't hurt anything. You know what I mean? But you didn't need to do it on this problem. Let's do another. Yes? What should we do here? Add 1. Love it. Now what? Can I distribute these exponents? I just make that x to the 3/4 plus 2 to the 3/4. What do you guys think? No! No! And you're probably thinking, wait a second here, Mr. Kulik. We just did something like that a moment ago. And I would say, no, we didn't. We said a times b to the n is equal to a to the n times b to the n. That's fine. But a plus b to the n is not a to the n plus b to the n. This guy is bad. That's not true. Please, 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 exponents do not distribute across addition and subtraction. In my college program, we call this the freshman's formula because this is a mistake that college freshmen make all the time where they start distributing exponents. It's said kind of derisively that it's a silly mistake that you're not supposed to make. Anyways, okay, so we're not going to distribute these exponents. We've made that quite clear by my emphatic knowing. What should we do then?
Line that.
Well, no. We need to cancel that exponent out. So let's do the reciprocal exponent to both sides. Is that okay with everybody? Now, the 4/3 exponent to both sides, is that an odd root or an even root? It's an odd root because the denominator is an odd number. So do I have to worry about a plus or minus here? No. Just get one answer. And 8 to the 4/3 is 16. Who's impressed that I did that in my head? You don't have to be. It's not that impressive. And then obviously the easy last step is just subtracting 2. Should I check this? Yes. Why should I check this? Yeah, since the original problem was an even root, the denominator is an even number, I can get an extraneous solution here, so I should check this. Now, the place where we're going to, I shouldn't say that. Let's just check it. It's not that simple. Not for this one, anyways. Okay, 16 to the 4/3 is, or to the 3/4 is 8. And 8 minus 1 is definitely 7, so we're good. Again, you don't need to write down the checks when you're doing things unless you really want to. Just put like a check mark next to your answer to cue to me that you've checked it. Okay with that? But you don't need to write anything more down than that. Everybody, so far so good. Yes? I'm going to stop here. We have some more complicated